Hello everyone. In this session we discuss about fuzzy logic control. Fuzzy logic control in AI is a method that uses fuzzy logic to handle imprecise and uncertain information in decision making of a control systems. So this fuzzy logic system was proposed by Professor Latif in 1965. So it is most used logic in many applications in real world. What is fuzzy? Fuzzy means which is not a clear. Meaning of a fuzzy means things that are not clear. So things that are clear we can say it as a crisp logic versus fuzzy logic. What is the difference means? Suppose if you ask any question, a fuzzy answer, if it includes words like maybe, may not, absolute, partial, extra, these kind of words are there in your answer, we can say that that answer is a fuzzy answer, means that is not clear. We can't take any decision on such kind of answers. Everybody expects only crisp answers, means crisp logic. Suppose if we ask one question, is it hot water? Then if you give either it is answer, if your answer is yes or no, means 1 or 0, then your answer comes under Boolean logic, which is a crisp logic, means you have given a clear answer. Suppose your answer says that very much, little, very less, then your answer we can say it's a fuzzy answer. But many, if you see the problems, most of the problems they come under this category, means decision making, because decision making in any environment depends on its certainty. Means most of the environment in AI systems, they are uncertain. Uncertain means taking a decision in uncertain environment is difficult. Means environment, if environment is uncertain and imprecision, automatically taking decision is also it's a difficult task. So how we deal this situation? Through logic, means we apply this our fuzzy logic things. A fuzzy logic basically what we do, we give one member function or objective function. We prepare a objective function that assigns some value to the answer. Suppose if I ask is it hot water, my member, I define one member function that generates a value between 0 to 1 and assigns that value to the answer. Like if 0.1 generated means it's a very less, 0.25 little, 0.9 very much. So we take these values and we process those values for taking the decisions. Like this crisp set means crisp logics, they have a set of values, whereas fuzzy logics they use a fuzzy set where it's a ordered pair element and a membership value of that element in that set. So how this fuzzy logic is used in our control systems, means control systems they have to take decisions. Decision making is difficult without fuzzy logic. Let us see one example. Now we in our day-to-day life we experience this problem. Suppose you go to a restaurant and a waiter serving you. Generally a waiter brings a food and service to the customer, and after at the end of that dinner something, customer wants to give tip to the waiter. Generally we experience this situation. Now we decide our tip, whether how much tip we give it to the waiter. The decision itself is a fuzzy one, means we are not clear how much tip we give to the waiter. So what we do, we prepare some rules in our mind that if service is poor and food is rancid, then tip is cheap. Means if waiter both food and service if they are bad, your customer don't like to give any tip. So he prepares that rule he prepares in his mind. Similarly, if service is good and if service is good, if food is bad, still he tries to give an average tip. When service is excellent and food is delicious, then a customer wants to give more tip. So this simply here in our mind we apply our fuzzy logic only to take a decision. How much tip we give it to the customer. Here the same thing if we apply in control systems, where you have a fuzzy crisp inputs, and there is one fuzzification module that decides what to do with this crisp input. Like here, food and service are input to our brain. In our brain we have one module that gives this data to the inference engine, and we framed some rules. Like here, these are the 3 rules. If service is poor, food is bad, tip is low. If service is good, tip is average. If both are good, tip is excellent. These rules I store in a rule base, and how much tip is given, that is stored in fuzzification module. These are sent to inference engine. From inference engine again I send it to the defuzzification and crisp value. Means this is nothing but application of a fuzzy logic. Now how this fuzzy logic used in control systems? What is a control systems? A control system is an arrangement of physical components that is defined to alter another physical system so that the system will exhibit certain desired characteristics. Means control systems, if we take a control system, like if we take example of a washing machine, we use washing machine regularly. Washing machine uses fuzzy logic system inside. Means there are 10 programs on the washing machine based on the nature of the cloths we put in the washing machine, and hot water or cold water. For those based on those, it has to take the decision how much time that washing machine should run. This is indirectly example of a fuzzy logic only. Here a physical component means one physical component. So buttons on that washing machine, when you press those buttons, every button is like it is something, some action is programmed with those buttons. When we press that, it is changing behavior of another component, internal component of that washing machine. So here arrangement of those physical components are defined to change certain characteristic of another component. Such systems we call them as a control systems. We have 2 types of control systems generally: open loop control system and closed loop control systems. So washing machine comes under open loop control systems. The input control action is independent of the physical system output. Suppose I start a washing machine and I set the timer as 20 minutes. So it doesn't, even though there are less number of cloths, it won't stop. It will continue until it finishes 20 minutes. Such kind, there is no feedback from the user. Whatever task it is designed for a certain, it has to complete, whether water is sufficient water is there or not. It doesn't take any feedback from the user while its execution. What it do, starting to ending, it will complete its task. So such kind of systems we open loop control system, where they don't take any feedback from the user. So closed loop means control systems like AC, our air conditioner is also comes under this category. Closed loop control system, we have a remote for a AC. That remote has some controls on the buttons. Now, so AC uses a fuzzy logic. How a fuzzy logic it applies means it has to decision how much temperature set to reach a room temperature. So room temperature is controlled by our remote. So based on the number of people, automatically it decides how much temperature it should set by sensing the temperature of the environment. If we take humidity and temperature, based on those 2 inputs, our AC decides how much speed should be, like fan speed of that AC is decided with the temperature and humidity. So here every time it asks the user is it okay, means you are increasing the coolness, hotness through our remote, means it is taking a feedback from the user. So such kind of a control system we call it a closed loop control systems. So our AC is example of a closed loop, and internally it also uses a fuzzy logic system. How AC is, let us see how AC fuzzy logic is designed while it is manufacturing. Suppose inputs to our air conditioner is temperature and humidity, and one member function is there that decides cold means 0 to 15 degrees, warm means 10 to 25 degrees, 20 to 35 degrees is hot. For a member function decides these values, whether the room is cold, warm and hot. And humidity, these are two input parameters to my AC. Output of my AC is fan speed. Fan speed, it may be low speed, medium speed, high, between 0 to 100, moderate. So it has to decide this fan speed. So we cannot apply crisp logic in this system. Crisp means exactly medium means medium, high means it has to decide this fan speed based on the outside atmospheric temperature and the number of people inside, means how much current room temperature. So here I apply a this fuzzy logic. So fuzzy logic starts with the making a rules. So fuzzy logic, first we design the rules of our AC. Like if temperature is cold and humidity is low, then fan speed is low. If temperature is warm and humidity is medium, then fan speed is medium. If temperature is hot and humidity is high, then fan speed is high. These are the rules I define on my AC, and these are the two inputs, and this is the output of my AC. So now this uses a fuzzy logic. How to set the fan speed based on the rule. If the input, suppose the AC remote gives the input temperature as 22 and humidity as 65. So immediately one member function that is defined, a fuzzification process starts, and member function allocates the values for each parameter that AC is defined, 0.3 for cold, 0.7 for warm and 0.2 for hot. So and humidity also, there are for each fuzzy answer it assigns one value. So rule evaluation performs a room evaluation, and whatever 0.5 is taken as its output value. The defuzzification says that only 60% of fan speed is enough to bring that room into a human normal temperature. So like this, a fuzzy logic helps in a uncertain environment, because AC works in an uncertain imprecise. One day there may be very hot, one day it may be very cool, and after starting AC also suddenly if there is a rain, it has to adjust its fan speed immediately. So such kind of uncertain imprecise environments, fuzzy logic is very useful, and the control systems, they take help of this logic. Now how this simple fuzzy logic controller, if you take its design, first it takes the input and it normalizes this. Normalizes means between 0 to 1, how much in our AC condition I told you it has fan speed is 0 to 1 scaling factors, and input is also normalized and is sent to the fuzzifier. It has all rules are stored in rule base, fuzzy knowledge base, our member functions values, those are stored here. Fuzzifier, this entire after process fan speed is given as the output. Whatever I explained, that is described in this diagram. Please go through this one. You will get an idea how controllers are designed using fuzzy logic. So steps in a fuzzy logic controller: first we identify the input and output, assign each fuzzy subset a linguistic variable or descriptor, obtain the membership function for those descriptors, form a fuzzy rule base, fuzzification and evaluate the rules, and then perform defuzzification. These are the steps involved in designing any fuzzy logic control systems. So what are the applications of FLC? This fuzzy logic controlled in many real world applications that we see in our everyday, we can experience them in our day-to-day life. We use this in traffic control, how much traffic is there, which route should be cleared and which route should be stopped. So steam engine, aircraft flight control, missile controls, adaptive, liquid level controls, helicopter models. So these are all applications. They basically work in uncertain environments. Uncertain always require a proper answer to take the decision. So fuzzy logic is very useful. With the help of a member function, it can decide the outputs. So these are member functions and fuzzy sets, clear sets that we covered in previous sessions. You please go through that and verify this one. You will get an idea. Thank you.